firstly, we start off with this problem to motivate our thing, which is completing the triangle. We have this complex number, and we want to find the largest possible real part, so the parts that don't have I in them. And also we know that z, which is like a variable, is just some complex number, and the
Modulus.
z is 4. So we could write then z as 4 times cosine theta plus I sine theta. If you are unsure why we can do this, think of it like this. If z lied on the unit circle, it would be cosine theta, because cosine theta is like your distance along the unit circle for some value of theta. And then its height, if it's on the unit circle, would be I sine theta. I sine theta, because the height is like your imaginary part, and also your height is sine theta because you're on the unit circle, I said. But here, really, if saying that the modulus is 4 is the same thing as saying that the distance from this point to the origin is 4. Or in other words, it's just a point on the unit circle of radius 4. So the not unit circle, the radius 4 centered at the origin circle. So same idea as this, but we just scale it by 4 to make it correct and not wrong. Okay, let's start solving this problem. Something you might notice is that this would be really easy, right? We have you could rewrite this part as this times 1 over z. But we really don't like 1 over z. Like, it'd be really nice if it was just if there was a z on the top. If there was a z on the top, that would be so chill. But I can't just add a z on the top. I can't just multiply this by z. And even if I multiplied it by z divided by z, we would still have a z squared on the bottom, which is totally not chill. So I will have a solution. Let's multiply the top and bottom of 1 over z by z conjugate over z conjugate. And so now this will become the absolute value, or the modulus of z squared, is z times z conjugate over z conjugate. Wow, this is really nice, because this is just a real number on the bottom. Specifically, we said the modulus of z is 4. So the modulus of z squared would be 16. That's z conjugate over 16. Whoops. Wow, this is so much easier to work with. Let's rewrite our problem statement. 75 plus 117i times z plus 96 plus, let's make a boundary, 114, 144i times, this part is going to be times by z conjugate over 16. So in other words, you could think of this as very nice. This is what we are working with now. And it's nice because I only have real numbers on the denominators. And also, not only that, I can divide this 96 by 16, and I can divide this 144 by 16. And that's really nice, because that will give us this. Sorry, that took me a little while to think about. Okay, and remember we said that this is our formula, our expression for z? Very nice. So that means we can rewrite this like so. 75, that's a factor of 4 from this whole thing. So it'll be 75 plus 117i times cosine theta plus I sine theta plus 6 plus 9i times z conjugate. Very nice. And z conjugate is going to be cosine theta times minus I sine theta. 75 plus 117i times cosine theta. That was a minus sign. Okay, now let's just multiply this out. But remember, the problem said we want to find the largest possible real part. So I'm only going to multiply this stuff that's real. If it's not real, then I don't really care about it. And that will give us this. Now let's combine our like terms. So give you 81 cosine theta minus 108 sine theta. Wow, this is really cool, because now we could factor out 27. So now it's 27 times 4 times 3 cosine theta minus 4 sine theta? Wow. You know what this reminds me of? You know what this reminds me of? Do you know what this reminds me of? This reminds me of a 3, 4, 5 right triangle. Wow. So let's draw a 3, 4, 5 right triangle. And we already used theta, so let's use like alpha. Oh yeah, alpha. And, let's say I want cosine theta to be like have a 3 in it. So let's say like this is 3 because now it'll be adjacent over hypotenuse. This is 4 and this is 5. So the cosine of alpha will be 3 over 5, and the sine of alpha, opposite over hypotenuse, is 4 over 5. Wow. I see something pretty chill and nonchalant coming up. But to do that, I'll need to erase this stuff. Very nice. Okay. Would you guys want to know what I'm thinking? So like, I feel like there's a 5 here, but there's no 5s here. I want a 5 to be here. So what I'm going to do is I'll just like multiply this. Like I'll factor out a 1/5. Or actually I'll factor out a 5. And you might say, well, there's a 227 times 4. You might say, well, there's no 5 in this. And I would say, yeah, you're just not looking hard enough. So 3/5 cosine theta minus 4/5 sine theta. Because now this 5 will make these 5s cancel out. Wow. You want to know something I just realized? 3/5 is cosine alpha, and 4/5 is sine alpha. So this is 27 times 4 times 5 times cosine alpha cosine theta minus sine alpha sine theta. But wait, this is just the cosine addition formula. This is literally cosine of alpha plus theta. So we have 27 times 4 times 5 times cosine of alpha plus theta. This is the real part. And so when will this be the biggest? When will 27 times 4 times 5 times cosine of alpha plus theta be the biggest? Well, cosine of alpha plus theta, like this will be the biggest when this is 1. So let's just say this is 1. So then it's 27 times 4 times 5 times 1, which is literally just 540. So the biggest possible real part is 540. Wow, that was a really cool problem.